Hello everyone, let's take a look at an example related to cumulative distribution functions, CDF. In this problem, they give you the probability density function f of x equal to 0.02x when x is between 0 and 10, and f of x equal to 0 for all known value of x. And they ask you to find the formula for the cumulative distribution functions, capital F of t, and then you're going to sketch a graph for this function. As you remember in class, we have capital F of t is equal to the integral from negative infinity to t of the probability density function. Because the cumulative distribution function related to probability density function, so let's take a look at the graph of the PDF given to you right here. So you can see that on the left hand side of 0, the function is 0, and on the right hand side of 0, the function is also equal to 0. But between 0 and 10, you have the function equal to 0.02x. So that means you have three intervals to consider for the value of t. The first interval, so three intervals. The first interval is t less than 0. The second interval is t between 0 and 10. And the last interval is t greater than 10. When t is less than 0 and you want to find the formula for f of t, you have the integral from negative infinity to t of f of x dx. But you see the probability density function, when x is less than 0 is equal to 0, therefore the integral is going to be negative infinity to t of 0 dx. The CDF is equal to 0. Now for the second interval, when t is between 0 and 10, and you want to find the formula for the CDF, you have to use the integral from negative infinity to t of f of x dx. But not only that, we need to consider t between 0 and 10, we have to include whatever you have when t is less than 0 as well, because you have the integral going from negative infinity to t, right? So this integral can be written as integral from negative infinity to 0 of f of x dx plus the integral from 0 to t for t it's between 0 and 10, right? This of f of x dx. For this integral, right, because the probability density function in this interval going to be equal to 0, so therefore the integral is equal to 0. Now that means you left with the integral from 0 to t of f of x dx. So now when you consider the probability density function, you have to consider x between 0 and 10. And for x between 0 and 10, the probability density function is 0.02x dx. So this definite integral becomes, so I'm going to take 0.02 out because that is the constant. You're left with the integral from 0 to t of x dx. And the antiderivative of x is 1/2 x squared. You evaluate it between 0 and t. Then 0.02 simplified with 2, you have 0.01 times x squared evaluated between 0 and t. So this is 0.01 t squared minus 0.01 times 0 squared. And the CDF when t between 0 and 10 is 0.01 t squared. Now we have to consider the last interval. That means t greater than 10. F of t is equal to the integral from negative infinity to t of f of x dx. At this point, we need to break the integrals down to three different integrals. So you have the integral from negative infinity to 0 of f of x dx, plus the integral from 0 to 10 of f of x dx, plus the integral from 10 to t of f of x dx. Okay. So now let's take a look at the probability density function, right? For this interval from negative infinity to 0, the probability density function is equal to 0, so therefore the value of the first integral is equal to 0. Similarly, the probability density function when x is greater than 0 is also equal to 0, so the integral value is 0. And you're left with the middle integral. This is the integral from 0 to 10 of f of x dx. And for the probability density function when x is between 0 and 10, that is 0.02x dx. And if you use the calculator, or you can do this algebraically, you will get that CDF is equal to 1 when t is greater than 10. Now let's put everything together. So f of t is the function that is equal to 0 when t is less than 0. This is equal to 0.01 t squared when t is between 0 and 10. And capital F of t is equal to 1 when t is greater than 10. So this function matches with the CDF properties, right? The left end behavior is equal to 0, corresponding to impossible events, and the right end behavior is always equal to 1, corresponding to the sure events. Now we're going to use this information of f of t to plot a graph of the function. All right, so I'm going to draw this quickly. Here, the horizontal axis is t, the vertical axis is capital F of t. When t is less than 0, capital F of t is equal to 0, so you have the blue line right here. When t is between 0 and 10, you have something like a parabola. All right, so I'm going to draw something like this. And in the last interval, when t is greater than 10, the function is equal to 1. So at this point, I'm going to draw this horizontal line, and this is, of course, equal to 1 at this point. This should be 10, this should be 0. So this is the graph of the CDF.